I despise Genshin Impact. It is the worst game that's ever existed, and I really hope that they never even think about making another game like that. Cool. Okay, so today, one little extension, we are going to work through a system like this. Now, this is fundamentally different looking than anything that we've done in here so far, and maybe anything that you've ever done. I'm going to give you guys a second, get this jotted down, and I want to make sense of what is this even asking me to do? Like, I see that there's X and Y and Z. Why on earth would there ever be an X, a Y, and a Z?
Generation.
So generation, maybe. Looking at it, have you guys ever done three variable stuff? Okay. What does this three variable stuff represent? Say it again. Points? Kind of. Like, you're not wrong. There's points in here for sure. When we get an answer, is it going to be X, Y? What do you think it's going to be? X, Y, Z. Now, as we look at this, you guys have never done any three-dimensional graphing. We will not do any three-dimensional graphing. It's terribly gross to try to do it nicely. But here's the deal. We don't need to be able to graph it to be able to solve these equations. We could be working in four variables if we wanted, a four-dimensional space. I can't imagine what it looks like. I don't think anybody else can. Have you ever seen a four-dimensional shape? You ever seen a representation of a four-dimensional shape? So you've seen 3D, I agree. We live in three dimensions. What's a four-dimensional shape you guys have seen? Anybody ever heard of a tesseract or a hypercube?
Yeah.
So those are four-dimensional cubes. Now, obviously, as human beings, we can't make sense of it, but we can kind of get a justification for how one would try to imagine it if we could. If I take a cube right here and I cast a shadow, it goes from a three-dimensional shape to a what? So from a shadow, if I have a cube up here and I shine a light straight down, it looks like a square. Would you agree with that? So imagine that you have any box that you've ever seen. You just put a flashlight above it. It's going to cast a shadow that's the shape of a square, right? Okay, so we have a three-dimensional object cast a two-dimensional shadow. What do you think the shadow of a four-dimensional object is going to do? A three-dimensional object. Now, we can't imagine it. Again, what we are seeing right here, instead of just three-dimensional shapes, these are essentially planes. A plane, from geometry, you guys remember it's just a flat surface, right? Now, if I have three planes, or two to start with, I can have two planes intersect, as long as they're not parallel with each other. When they intersect, they form a line, right? I can see that that happens. Everybody okay with there's a line? Nice, probably not perfect. But if I take two flat surfaces, there's a very clear line between my fingers. Okay, so if you give me two planes, and I say, how do they intersect? And you don't even need to recognize that they're planes. I'm telling you they are. I know that two planes intersect in a line. What if I sneak in a third one in here? Is it possible that they intersect in a line? Like, I can do it just right, and I still don't have enough hands for this. I'm just going to fold this one and pretend like we can see it intersecting, okay? I could have it intersect just like this, and we still get a line out of it. Or, I can imagine three surfaces, and this one's super hard to be able to spot out. If I sneak in a third surface, maybe that's not the exact same orientation. Will somebody help me? Then we hold that. This whole just needs to be flat. Okay, two planes meeting in a line. If I have another plane coming through like this, I'm only going to get one single point of intersection right here. A singular point in three-dimensional space. Now, to make sense of what that looks like, we can graph on the board, right? So if I were to look at the board, and this is hopefully not just losing everybody, this is the point 1, 2. If I claim this and I write it, you guys believe me. What if I wanted to make this the point 1, 2, 3? Where does it move? Right now I have X dimension and Y dimension. Could I pull this point out into the third dimension and have it come out 3? Yes. It's hard to imagine, but you can see if I could physically pick it up and move it out, I'm now in the third dimension. That's all that we're seeing happening. We are going to get a line, a point, or possibly no solution, and we'll see what that looks like. But let's dig in. This looks harder, right? Now, 3 equations is challenging because you have 3 variables. But if we can boil this down to a problem that we've seen before, I think it's going to be easier. Does everybody have this written down in your notes? All right. So here we go. What are the methods that we've seen just to solve systems in general? Substitution and elimination. If I could somehow eliminate one of these variables, so it was now just 2 equations and 2 variables, would the problem be hard anymore? It would look exactly like the problems that we did yesterday. Now, looking at this, any variable that you want to eliminate, anything obvious, or substitute if you'd rather. I'm going to give you 30 seconds. We can use elimination. We can use substitution just like we did the other ones. But I want you to talk with your neighbors. Help me decide. 30 seconds. Right now, substitution or elimination. How are we approaching it? Talk with your neighbors. What do you guys think? Elimination would work. It won't be fast. I'll tell you that. And you might not see it yet, but the reason is we would have to pick two equations and eliminate a variable and another two equations to eliminate the other. Now, it would work. It would work. 100%. All right. Looking at it, we have a couple options here. We're going to get a Ronaldo. Thoughts? Elimination. Who else agrees? We could eliminate. What makes you think elimination? Just out of curiosity. So you notice that we can get the z's to fall out. Okay. If we use elimination, and we can, I'm going to suggest substitution, but I do want to talk about the elimination if that's what you guys saw. Could I write these two together and eliminate the z? Like I could come over here and rewrite just those. 2x minus y, and we're going to do it a different way. But I could write these two equations, 3x plus y plus 6z equals 4, and I could eliminate the z's out of this, right? And then I could pair up these two as well, and I could eliminate the z again. Or I could pair up these two instead. I could eliminate the z. Now, elimination will work, but it means that we have more systems to solve. In contrast with elimination, what's the other option? So when I'm looking at this, is there a single equation out of those three where I could easily solve for one of the variables? Which equation and for which variable? I see the third one for x. Now, you could also solve the middle one for y or the top one for y pretty easily, but for Scovia, I'm going to go with yours. I'm going to solve this third one for x right now. What do I get if I try to solve that for x equals something? What do I have to do to both sides? Okay, if I subtract 2y and 9z from this side, I wind up with this. Okay, the only thing that might be weird about this is I always try to write my variables first. You might look at it and want to write negative 16 minus 2y minus 9z. That's okay. I just rearrange it while I do it. Anybody not understand what we've done here? Okay? What do y'all think we're going to do with this x value? Where? To one of them? Both of them. I want you guys, and I'm going to give you a head start. I want you to take this value of x that we just found. I want you to plug it into the 3x in the middle equation and to the 2x in the top equation. So I'll help you with the first one. I'm going to take this value of x, Sebastian, and I'm going to plug it in to my other equations here and here. So if we do the first one, I'll help with it. We get 2 times, what did we say x was just now? Almost. Negative 2y minus 9z minus 16. And all I've done is replace the x, right? Yeah. Minus y still, minus 3z. And that is now equal to 20. I want you guys to do the other one. Clean this up for me. We'll do the other one here in a minute. I'm going to pause my video. I'm going to give you guys a head start. We're going to have 2 equations that only have y's and z's in them here in just a moment. I'm going to give you guys a second. I'll walk around, and then I'll start working it, and we'll see if we agree. Okay. We wound up with a kind of weird situation. If we solve this system, and this is what we would do, I don't know that we really need to do it, though, but we'll go from here. All we have to do is now just build our second system. Now we get a nice system in how many variables? We only have 2 variables. Now, if we tried to solve this, things are going to come up weird. That's 17? 21z, okay. If we try to solve this, can anybody tell me what's going to happen when I say how many points of intersection does this line have at the exact same line? Infinitely many, right? In this situation, what we just encountered is that two of these planes are the exact same. It means we have infinitely many solutions. This is one of the weird outcomes. We are done with this problem. If we get the exact same equation and we can see that they have infinitely many, we can then conclude from this one, therefore, our overall system has infinitely many solutions. In pre-calc, what we will do as an expansion is we will find exactly what those solutions look like. There is a very specific line that we have just found that shares itself in common and every answer is going to look like. Okay. There's a bit more work involved with a system with three equations, right? Is it fundamentally any different than what we've done? We eliminate a variable and then we solve it. It just, instead of getting a nice, easy variable right from the get-go, we have a new system that we get to solve. Okay. If you get the same line on both of them, infinitely many solutions always will happen. What if we get some silly statement, something that it didn't happen here, but what if I wind up, when I solve it, I get something like 0 equals 5? When is that ever true? Is 0 ever equal to 5? No. So if we get something like that that's absolute nonsense when we look at it, how many solutions do you think we're going to come up with? 0. We could have three planes that are stacked like this that never intersect each other. That could happen. Cool. Doable. Prove it. I have one more for you. This one will have a solution, just so you guys are aware. And let's check it out. I had a nice one. I'm just trying to remember where it is. All right. One more. I want you guys to practice with this. I know that there's one person who we had some algebra error in here. It happens. I will come help you find it. But I want you guys to do one more system for me. Here's a 3x3. I'm going to give us about 5 minutes to do it. Work with your neighbors. In solidarity with hard mathematics is not a great idea. Okay. For this, the most common mistake that people make is writing something down incorrectly. So I'm going to speak super slow and clear. Our first equation, x plus y plus z equals 3. Second equation is x minus y plus z equals 1. And last but not least, we get x plus y minus z equals 2. I would personally use substitution. It's how I see it easiest, but you don't have to. If you would rather use elimination, you are good to do that, but you're going to have to do two systems to begin with, followed by the third one that we get. I would substitute. Cool. I'm going to give us about 5 minutes. I'm going to be walking around to help as people need it. Work with your neighbors. Talk it out. Cool. Starting right meow. When I plugged in this value of x into the middle equation, I wound up with this. And notice, this is an equation. It just happened to give me exactly what y is equal to. When I plug this same value of x into the bottom equation, I get this. And here's what I see is coming down the pipe. I get that and that falling out, right? So I'm going to wind up with one more step, negative 2z. I'm just combining my like terms here and here. Plus 3 equals 2. And I get negative 2z equals what? Negative 1. And I would wind up with z equals what? 1/2. Now this one looks silly, and it works super nicely is why it's going to look silly. I would put a star here. On the previous problem, it was a little bit uglier, right? But what we really have now is a system of two equations where it seems silly to even write it, and I normally wouldn't, but I just want to make sure it's clear what's happening. We have this system of equations is what's on the board right now. Do we have to solve that system, or have we already done it just by virtue of doing the problem? Like, we already have it solved, right? But this is the system that we would solve. It just happens that it worked out perfectly. At this point, I know y and I know z. If only there were a way that if I knew those values, I could get x and y. Sorry. If I know y and z, if only there were a way I could get x. Oh my gosh, this says if I know y and z, I can solve for x. So let's try that. Once we get these values, and whether you solve for x or y or z, it doesn't matter. Sunny, by randomness, not really random, he chose to solve one of these equations for z, and he's going to get the exact same answer as I do solving it for x. If anybody here solved it for y, we're going to get the same answer. Here we go. A little bit more scratch work. I'll use red this time.
We know that x is equal to negative y. What was y? There's 1, and I can see that. So here's negative y minus, what was z? 1/2 plus 3. What's negative 1 minus 1/2? We're not in a kitchen, though. I don't want to mix number. Anybody opposed to this? Like you're opposed or you're okay with that? Okay, plus 3. And if we wanted to play the fraction game, we can, but I'm pretty sure I'm going to get 3/2. I now have a value of x, I have a value of y, and I have a value of z. Before we write our answer, what should we always do? Plug it in. Okay, we're going to divvy up the labor. Did you guys get the same x, y, z?
Yeah.
Plug it into the top equation, you 2 rows, those x's, y's, and z's, verify it works. You 3 rows, I want you to plug it into the middle one and verify that the equation that we started with is true. And you last 2 rows, you're going to plug x, y, and z into this bottom equation and verify that it's true. We're going to divvy up the labor here. It's not true? 3/2 plus 1.
Actually, it is. Yeah, it is.
I think it is.
Yeah, it is.
Lost my z value. Plus 1/2. 2
2
plus 1 is 3. Top one checks out. Middle one would be 3/2 minus 1 plus 1/2. So that's what? 2 minus 1 is 1. That checks. The bottom one would be 3/2 plus 1 minus 1/2,
Yeah, checks out.
which is 2. All 3 of these equations are simultaneously true. Is our answer good?
Yes.
Check it out. We have no doubt in our mind that our answer is indeed correct. Therefore, we haven't talked about it. Do you guys know the alphabet?
Yeah.
What comes first, x or y or z? And then? And then? So we don't have to get crazy. It's exactly in that order. 3/2 is my x, my y is 1, and my z is 1/2. And look at that. We have solved a system of 3 equations in 3 variables. Now, this is not the only way to do it. Have you guys ever done stuff with what is called a matrix? We're not talking like Neo matrix. Have you guys ever seen the word matrix in math before? If you're not sure, have you ever seen anything that looks like this? With these brackets around it. Okay, so turns out there's another field of math that's related to this that works really nicely. Later in the year, we'll see this again, and this is kind of a long problem, for sure. We will see a maybe faster way once we develop a little bit more math. Cool, cool. All right, this is a pretty involved problem. How are you feeling with it?
Okay.
This weekend, I have a super chill homework for you to do. Okay, I'm going to give you the whole assignment with the understanding that I'm lying. I'm going to give you 2 problems, I think. On Monday, we have 1 more little thing to knock out, and then we will finish the section. I'm going to give you homework over the weekend. I will add problems to it on Monday. If you elect not to do this over the weekend, you'll be okay because you're going to get another day, but it might make your Monday night kind of miserable. Cool. Your choice. So, your homework. And we'll come here. And I'm going to amend this. Your homework this evening. You will find on page 50. We'll call this homework 1.6.2. It is not going to be 19 through 22. You have 2 problems is all I need. 19 and 20. 2 problems this weekend. I'm going to add a few more problems on Monday once we cover the last little piece. This is all that you have. Are there events, Raider events going on this weekend?
Yes.
What? At the park tomorrow?
Yeah.
What time? Okay. Assuming that I don't feel like death tomorrow, I will see you guys there. 4 p.m. tomorrow? Okay. Cool.